All right. So I've decreased the resolution. Maybe these videos will load faster and we can get the ball rolling. Okay, so yesterday, the last video was on identifying all of these parts of the toolbox, and hopefully you put that in your notes from yesterday. Okay. Now, what I said yesterday is you might not understand what any of this means. All right, and the idea behind the toolbox is this is not. I'll tell you what it's not. It's not a step-by-step procedure. Okay? This is where you can go to get that spark to help you get to the next step of what we're about to do. And you have no idea what we're about to do. It's weird. Okay? What we're going to be doing for the next week and a half is not like any math you've ever done before. Right? We're not solving, we're not going to see a lot of numbers, quite frankly. Okay? We're going to see a lot of trig expressions. What we're doing is almost like proofs. It's just like a series of substitutions and simplifications over and over and over again. Substitute this thing in, then simplify what you see. Okay, now I'm stuck. When you get stuck in what we're about to do, you come back here and you find one of these tools to see, can I use this tool for this job? Okay, I can. So I'm going to do this and then I'm going to go through it. Okay? So we'll talk about, we're going to run through the best way to do this, quite frankly, because I've been speaking in some of these ambiguities and like kind of confusing, like when we start doing this, you're like, well, what are we doing? You haven't told us what we're doing. Like, we're about to start. The best way to learn this stuff is just to do as many examples as possible. And that's all we're going to do for the next 3 class periods, in person and at home. Just practice, practice, practice these problems. Okay? So, the first problem looks like this. Now, the directions are very simple. Okay? The directions are going to say simplify. And simplify means take something that has 3 trig terms in it and make it simpler. Okay? And we do that, we start with this, and the very first thing that we're going to do is use one of these tools to start simplifying it. Okay? So what I'm going to do is I'm going to toggle back and forth here for now and say like, okay, let's take a look at this. Now, I'm going to walk you through each one of these. This first video is going to be a little bit longer than the rest, even though the problem itself is pretty quick. I'm going to talk you through the talk aloud, right? First of all, one tool that you can use is to look at all of the terms and write each one in terms of sine or cosine. So if you look at our, I'm not going to write that down, but if you look at our identities from yesterday, every single term can be written in terms of sine or cosine. Tangent is sine over cosine. We wrote that down yesterday. Cotangent is cosine over sine. Cosecant, we wrote down yesterday, is 1 over sine x. Okay? Secant is 1 over cosine x. So one thing that I could do, and let's do that, is I could say, I'm going to take this, and I'm going to write it, I'm going to substitute in its place its equivalent form in terms of sine. So everything else is going to stay the same. There's a sine x here, that's this guy, right? Oops. And I'm going to take out the cosecant and put 1 over sine x, because in your notes from yesterday you have cosecant x equals 1 over sine x. That's just taking this out, putting that in its place. And on the bottom, I've got that. Okay? So what did we say? We do one of these substitutions, we use the tool, and then we simplify. So how would this simplify if we look at this, right? We have sine x times 1 over sine x. Well, think about this. Sine x, we can start to color code this if you want. This sine x is really sine x over 1. And this is 1 over sine x. And then on the bottom we have cosine x. Okay? Ow. So I rewrote the thing that wasn't a fraction into its fraction form. Because what happens when I multiply here? What do we get? Sine x over sine x. And what is sine x over sine x equal to? Any fraction where the numerator and denominator are the same is equal to 1. So what have I done so far? Substituted. I rewrote the problem so that it matched up. I didn't have to do this. If you were like, okay, I know that something like this times its reciprocal is going to equal 1. Maybe you're in tune that way. If you're not, we rewrote it as a fraction so that I could multiply. Then I get that, and sine x over sine x is equal to 1. And that, would you agree, that is a lot simpler than what we started with? Okay? I would agree that it is. Now, there's one more thing we can do to make it even simpler. Because 1 over cosine x, if you wrote down the notes from yesterday, you wrote down 1 over cosine x somewhere in your notes yesterday. Okay? If you want to go back and check, you can. Those of you that are at home, those of you that are in the room. You wrote something yesterday that said blank equals 1 over cosine x. And that thing is secant x. And secant x is a statement that is way simpler than 1 over cosine x. Okay? So this is what we're going to be doing. Taking something that has lots of terms that looks complex and substituting and simplifying it through algebra skills that you already have to end up with something a lot simpler. Okay? Now, before we wrap this problem up, notice I didn't do any of these. I just did this, right? Because I could, and I went with it, and it worked, and I got something simple. I didn't do any of this. I didn't have to, okay? So when we get to the next problem, we'll say, should I do this, or this, or this, or this, or this? We'll go through the list, okay? But I didn't have to go through the list because I did that, and I got something that worked. Now, I'm going to pause this and then start another video because I want to expand on this idea.